Hello, geometry students. Today I'm going to start talking to you about the area of regular polygons, but I have to break it into two videos. In this video, I'm going to prepare you. I'm going to teach you the vocabulary and skills you're going to need so that you can tackle the area formula for regular polygons. And then in the next video, I'll actually teach you how to use the area formula for regular polygons. And in this section, you're going to need to remember your special right triangle patterns, the 45, 45, 90, and the 30, 60, 90. And you'll also have to remember basic trigonometry from SOHCAHTOA. If you've forgotten any of those things, go back and review those videos now and refresh your memory before you go further. So just to remind you, regular polygons are polygons that are both equiangular and equilateral. All their angles are the same and all their sides are the same. The next vocabulary you need is epithem, which is a perpendicular segment from the center of the regular polygon, making a right angle with one of the sides. And notice if you have a five-sided shape, you could have five of them because you could make a right angle with any of the sides. If you have six sides, there are six possible epithems. And that's really important because when we get to the next video, you'll see that you need that length in order to use the formula for the regular polygons. More vocabulary you're going to need. When you draw a regular polygon, you can put a center point. The segment, as we've said, from the center, making a right angle with one of the sides is in red here, the epithem, and then the radii in black are segments that go from the center of the regular polygon to a vertex. So in this shape, A, B, C, D, E are all vertices of this, in this case, pentagon. And so we have five sides and five radii. Now, the next thing is central angle. The central angle is the angle formed with the vertex at the center of the shape, and the sides of the angle are radii. So in other words, the angle between the radii of a regular polygon is the central angle. Now, you can figure out the measurement because if you walk around this center point, that's 360 degrees. If there are five central angles, you can easily figure out the measurement of angle one. The central angle is 360 divided by how many central angles there are. If there are five sides, there are five central angles. In this case, 360 divided by 5. And then we have a theorem about isosceles triangles. Notice that all the radii are congruent. So all these triangles formed between two radii and a side, those are all isosceles triangles. And whenever you drop a perpendicular, when you drop the altitude from the vertex angle, it will perpendicularly bisect the side. And it will also bisect the central angle. So when we drop the epithem, which is basically the altitude of this blue, blue, black isosceles triangle, in that case, angle 1 will get bisected. So the measurement of angle 2 is the central angle cut in half, or in this case, 72 cut in half, or 36. And now notice the epithem, it makes a perpendicular, it's a perpendicular with the side, so therefore a little right triangle is formed. And we know that the two acute angles inside a right triangle are complementary, so we can figure out the measurement of angle 3. So now you try. Pause the video and find the measurements of the central angle, angle 1, the angle 2, and angle 3. So notice this is half of an octagon. If the whole octagon was shown, then you would take 360 divided by 8. Then again, you can see this is half of the shape, so you could also do 180 divided by 4. Either way, you'll get measurement of angle 1 is 45 degrees. And then when you drop your epithem, you bisect that angle, and so measurement of angle 2 is 22.5. And then the complement of that is measurement of angle 3, because a little right triangle is formed, and so you know the two acute angles inside the right triangle are complementary. All right, so now pause, draw the center point, draw the radii, draw an epithem, and then find all the missing angles. And then press play for the solution. All right, if you first of all draw in your center point, the black radii and the purple epithem. That's the first step. And then you can start finding your central angles. Since in this case, a hexagon has 6 sides, there are 6 central angles. So 360 divided by 6 will give you the measurement of angle 1. And then when we drop the epithem, this angle gets bisected. And so measurement of angle 2 is 30. And then we know that these angle 2 and 3 are complementary. And so we can find the complement. Now notice, in a regular hexagon, when you draw in all your radii, notice 6 equilateral triangles are formed. So notice that you just found out that this angle 60 and this angle 60, so 60, 60, 60, 60, 60, 60, 60, 60, 60, 60, 60, 60, only in the regular hexagon. So pause. Draw the center point, the radii, drop down and up at them, and find all the missing angles. So here's our picture. We drew the radii in blue. We dropped down the epithem in red. We found the central angle, 360 divided by 4, measurement of angle 4. Then when we dropped that down, that angle got bisected. And then we knew that these 2 angles are complementary. Pause, do the same steps for the regular triangle. So 360 divided by 3 gets your measurement of angle 1. Drop down your epithem, it gets bisected, measurement of angle 2, and 2 and 3 are complementary. Notice, when you have a regular triangle or an equilateral triangle and you do this, you're up to these shenanigans, notice that you also have a 30, 60, 90 triangle, but the orientation of that is different than it was in the regular hexagon. And those are the basics for the vocabulary you'll need to face the formula in the next video. So I will leave you with this picture of Cheez-It.